Okay, perfect. So, have you guys seen the last session? So on last session, I gave you assignment, and the assignment was you have to just place all the component under the system, the SOC, and mostly those components was pull-ups and pull-down resistors, all the bypass capacitors. Apart from those, you have to place DC blocking capacitors, and there was few diodes as well on the line. And yeah, so all the components whatever we have connected on these the blocks of RK3399 SOC, you have to just place those component under the system on chip, right? So as you can see, this was your assignment. Apart from those, I've added one more point on the assignment, and that was you have to assign the differential pair net classes as well as the net classes to club all the similar kind of impedance, all the tracks which has same impedance. You have to just club those. So I just did that for you, and if you wanna try that by yourself, so this whole schematic or this whole project will be you can use it as a reference, and you can see okay where you are making some mistakes and like that. So I just want to take you through all the things that what I have done for your reference. So things started from this one, and here you can see this is our SDMMC interface, right? So as I already told you on the last session, you can use blanket to to kind of assign the net class on multiple nets together, right? So here I have used blanket, and on blanket I've just put that parameter. And if you double click on this one, you'll see the net class which is assigned on this one is 50 ohm SDMMC. Okay. So here I had two options. Either I club all the 50 ohm interfaces, for example, this one and this one together. Okay. But again, the design rules for all of these are different. So I just wanted to differentiate as per the design rule, and I just want more control during the design. That's why I just separated those 50 ohm tracks by the name of their interface. Apart from that, here I've clubbed all the analog to digital converter pins, and here we have so again here what I did, here we are using two types of classes. So the first one is differential pair classes. So as I've already told you on the last session, if you double click on this one, so instead of adding a net class, I've added a differential pair class. Okay. And what I named that class, okay. So I guess there is one mistake. Hold on. So these are all the classes of PCIe. Okay. And same here. And you have to remove all these. Control C, Control V, double click on this and hide the name. So here what I did, I just kind of enable or you can say make its name visible, so I can able to see okay what types of differential pair are these and what is the impedance of that differential pair. Now I'm just going to copy that and place it here. Okay, now select both of them, Control C, Control V, and place these pairs together. So these are all the PCIe differential pairs, right? And all the and from the impedance table that I've shown you, let's open that again. So hold on. Yeah, and from the impedance table we can see the differential pair impedance for the PCIe TX, RX and clock is 100 ohm plus minus 10%. Okay, so we're going to use that 100 ohm here. That's why, that is the reason. Okay, so now it's fine. So here what I did, I've just assigned one the pair of the differential pair class. Another thing I've assigned, I just clubbed all these things together. Okay, so using that, so this is what I'm doing for all of the differential pairs in case of PCIe, In case of here, you can see, so here we have few differential pair net classes, and then I just clubbed all these together and assign a signal group of HDMI. Okay, so the reason of doing this is, so here you can see when I'll be using the differential pair net classes, and when I select that on the PCB file, it will select only these group of connections. Okay, it will just leave these two. Okay, so during the design, I just want to see all of the connections, all of the signal group which involved on in the HDMI connection or HDMI interface. I just want to see all of those together. So that is why I just clubbed everything together and just named that HDMI signal group. Okay, similarly here, so apart from all these differential pair classes, we have one more connection, that is the reference register of TX, and I just clubbed all these together, and you'll see it's another net class which is MIPI DSI0 signal group. Similarly for EDP, if we'll move to another one, here we have this USB 2.0 signal group, and similarly here we have USB. So what I did, if you double click on this one, you'll see the label and the net class name is the same one, which is USB 2.0 signal group. Okay, what I did here, here also I placed this same thing. You'll see it's the same, right? Name is same, label is same. So I just placed the same thing, but here you'll see another option, and using that you can change the style. So if I'll go for the large one, you can see it's overlapping and we don't have enough space because of component, so you can just make it tiny one. Okay, so this is again a way to place net classes. Okay, so here I made one more mistake. Okay, so that is, I just forgot to include these type C data plus and data minus connections with the signal group of this, and these are again differential. So what I will do, I'll just copy one of these. Firstly double click on this, so you can see it is differential 90 ohm USB type C, right? And the same impedance is for other differentials as well here. So firstly place those, and then we will place the blanket as well. Similarly here, just make sure blanket should not be overlapping, otherwise whenever you will select USB 2.0 signal group, this type C D plus then D minus will be selected, right? So just you have to avoid that. For signal group, I'll copy this same thing. For the type C and type C1, it is different. So this is the type C1, and I double click on this and make it tiny one, and another one is type C0. So here we have type C0 of signal group, and place that. So make sure it should be placed like this. Okay, and double click on this, and again it should be tiny one. Okay, now save the project file. So similarly I did the same thing for all the differential or single-ended connection where we have to kind of match the characteristic impedance as per the design guidelines. Okay, so if you just go through with each, so again for GPIOs, I2C, UART, we don't need any as per like impedance standard, right? So I just leave those things. Apart from that, you'll see all the MIPI interface, or wherever we needed like length matching and everything, the impedance, I've covered all these and just clubbed those into a net class or differential pair class. Okay, similarly for SDIO and yeah, so this is important. So for LPDDR4, what I did, you can see there are multiple net classes, multiple these tiny ones. Okay, so what are these? So firstly, if you'll open the impedance table, okay, so this is the impedance table of LPDDR4. and here I'm covering all the signals that we're going to use. Okay, and what are those signals? I've already told you on last session. So those signals are DQ, DQS, data mask, command and address, clock enable, chip select, reset, right? So these are all the control connections. Sorry, these are the control signals group. This is the clock, and this is the data group. Okay, and this is the clock group. Okay, the command and address group and clock. So here I mentioned all the impedance requirement for those connections, for those signal group. So for DQ, the impedance required is 50 ohm plus minus 10%. For DQS, it is 100 ohm because it is the differential signal. Apart from that, for DM, it is again a 50 ohm. So as you can see, for DQ and DM, the impedance requirement is 50 ohm, right? So I just did the same thing here. What I did, I just made a bigger bracket and covered all the 32 bits of DQ and all the 4 bits of DM. Okay, and its name is 50 ohm DDR underscore D. So that means it is just a data group. Okay, now what are these which is inside the bigger blanket? Okay, so again, we have 32 bits of data, and what if we'll divide those into data, you can say byte groups. Okay, so these are all the byte group, because when you see the footprint of LPDDR4, it is divided into byte groups. Okay, so the advantage of using or dividing those into the byte groups is during the connection or during the net classes, we can able to see which byte group is where it is connected on the SoC chip or on the RK339. For example, this byte group is connected here, this byte group is connected here. So that means when we see the connection, go to the view, connections, show all. Okay, so from here we can see, okay, this is going here, this is going here. Okay, similarly this connection is going here, so that we can visualize, and during the planning of layout we can able to, you know, we can understand, okay, where we have to connect the byte 1 of the LPDDR4 and where it is going. Either we have to change the layer, or we can route multiple bytes groups on the same layer, like that, right? So it is helpful during the planning of you can say the layout planning, right? So let's go back to that page again. Okay, so here what I did, if you double click on this one, you can see I just renamed that DDR underscore group 1. Okay, so this is group 1. If you click over this one, this is group 2. Similarly, this is group 3 and 4. Okay, same. So for group 1, the data mask signal is DM0. For group 2, it is DM1. For group 3, it is DM2. Okay, so similarly, you can see if double click on this one, the net class assigned on DM2 is G3. Okay, and similarly for this one, it is G4. So let's see what is the advantage of that. So if I'll go back here, and I'm just going to hide those again. Let's go to the PCB tab. From the panel, click over the PCB, and from here, okay, we have to select the net. Hold on. Okay, go back to PCB, scroll down a little bit. Okay, so now here you can see all the groups, or all the DDR group 1 classes and all the signals under those, right? And when I'll select those, when I select this one, you'll see all the group 1 will be highlighted. And what are the signals on this group? It is all the data signal, all the data mask signal, and DQS signal, data strobe as well, right? Here, this is data mask, and this is the differential data strobe for this byte group. Okay, similarly, if I select G2, you can see this is the G2. So how it is helpful during the placement, layout planning. So see, if I'll highlight G1 and G2, you'll see, okay, so G1 is going like that, and G1 is going like that. Okay, here it is, right? and G2 is crossing the G1. Okay, so that means from here we can understand, okay, if we are planning for layout and we know, okay, layer 2 and layer 3 or layer 1 and layer 3 we're going to use as a high speed, we're going to spread all the high speed tracks on those layers. So we will know, okay, we can't route group 1 and group 2 on the same layer. Okay, so that is one thing. Apart from that, so again those will be on different layer. Similarly, if we'll see for G3, so G3 is here and here. Okay, so one will be like this, another is like this. This we can connect from here. Okay, let's suppose we'll use this path to connect these. And where is group 4? Group 4 is outside that. Okay, so that means these are kind of in a sequence. Okay, if we'll use this path to connect G3 and G4, then these are in sequence. Okay, so from these highlighting these groups, we can able to understand, okay, what is our plan for layout. I hope you got my point. Let's go back to another one. Okay, so similarly here what I did, so these are all the DQS signals and these are differential. So firstly I have assigned a differential pair net classes here, and apart from those I've just added those into the groups. So if I'll double click on this one, this is for group 1. Similarly 1 2 3 4. Okay, now what these are the signals which is kind of common between the banks of LPDDR. Okay, so what is the meaning of that? Let me show you. So if we'll go back to schematic here again, or we can just I can demonstrate using the okay, so here you can see, and we already understand that so for the bank 1 and bank 2 of LPDDR4, the address lines are common, right? All the address lines are common, all the clock enables are common, clocks are different. Okay, but these are the lines which are common, right? So what I did here, if we'll go back here, so instead of just putting them into the the byte group, because these are not a part of byte group. Okay, this is the part of rank. Okay, so that's why I didn't included these address line and all these clocks and clock enable lines in the byte group. I hope you got my point. So that is one thing, and same thing I did for the another memory chip that we are using. Okay, that is one thing. Apart from that, I've assigned the net colors on DDR line, and from that we can able to identify, okay, where we have to place these capacitors, because when we select those and we have multiple pads of DDR, okay, so we can't able to identify, okay, which pad is left there, right? Or we forgot to place a bypass capacitor on that particular pad of LPDDR4 or system on chip, right? So that's why I've highlighted those with a color, and you can simply see on this as well. Okay, and similarly all these yellow lines. Okay, so you can see all these yellow are VCC DDR. Okay, and during the placement I make sure, okay, at least each pad has bypass capacitors on that, right? And whatever the extra bypass capacitors we have, I'm not deleting those right now, because right now we are just trying to fit every component on this board, and we will see how we have to spread the component. So as you can see here, we have a lot of space left, similarly here and in this section as well, right? So when we're going to place VIA, we have to just make a lot of space for those VIA placement, and when we place those V connections for connecting the pads and the component on the bottom layer. For that we needed enough space, and then we have to spread these component. So that's why we do this first iteration of component placement, and from there we'll get idea, okay, where we have to spread most of the component. So it will be like in this and this direction, and in this direction as well, right? So this is one thing. Apart from that, okay, let's go back to eMMC. So here I didn't place like net classes and nets, because I've already covered this interface, the other side of the connection. So this is the chip, and the same connection present on the RK3399. So we have placed here. So I placed net classes in at the other side. Okay, so you don't need to place these net classes or these blanket on both of the sides. Just select one net and it will be applicable on wherever you are using this net. Apart from that, yeah, so this is the one thing. So again, these are the different connections, and these are going to your DDR4 connector, and that connector basically we are using to place our system on module on the carrier board. So here you have to place a separate differential pair net, because these are differential nets, right? And these will be connected to RJ45 connector or the LAN connector. And there you can see I've just made the signal group and placed these differential pair net classes. Apart from that, for these MAC, RX, TX or clocks, we have already placed on the SoC. So that's it, and these are the things that the changes I did. And today, like when I'll be sharing the video or the recording of the whole session, I'll just share this document as well, so you can compare what if you did the assignment number 6. You can compare your placement of these component, whatever the component you placed on bottom, and if you tried these net classes, you can just see my thought process about these net classes and what you did. So whatever is better, you can just go for that. So let's start today's session. So what we're going to do today, so I'm just going to note down those first. Okay, so let's discuss that from the assignment, because I've already made that. Okay, perfect. So this is your assignment number 7, and here what you have to do. So if you skip the assignment number 6, you can start from that, and under the SoC you have to just place all the bypass capacitors, pull-ups, pull-down, reference resistor, diode, terminations, DC blocking caps, everything connected to RK3399 blocks. Okay, whatever the 25 number of blocks we made, whatever the number of component connected on those, you have to just place under the pad. Apart from that, the second thing or the second approach should be, if you'll go for other placement, you can go for that, but I always recommend you to start from LPDDR4, and from that we can able to identify, okay, where else the space left, and there we can place our other component. So let's start with LPDDR4 caps. So if you open so here we have placed these memories, and apart from these memories, we'll have lot of capacitors to place, right? These capacitors, right? Apart from these capacitors, we have these few reference registers and few pull-ups and pull-down we have to place, right? Similar for LPDDR SDRAM2. We have these many capacitors, which is almost same in number, and all these other component which is directly connected to on-die termination and reference registers, like that. Okay, so you have to just do that. After LPDDR4, you can go for the type C. So here the meaning of, so we are using two type C connectors, one for powering up the module, another one is for programming and debugging. So this is the debugging and programming one, and you can start from that because it has only few components, and then you can go for the Wi-Fi module placement. So this is the type C, and so I'm talking about firstly you have to start with this section, then this section, then this type C, and then Wi-Fi module. So for Wi-Fi module, I would recommend place all the components under this. Okay, because see, we have radio frequency connections, which is at this corner, one is here and another one is the other side here, right? So just make sure, because we have to route these tracks. So my plan is to route one like this and another one like this, okay, on these two connectors. So just make sure all the components should be placed here. I'm going to isolate those as well, but just make sure on the bottom layer, because we have to remove all the grounds. So if we're going to place some signals or some other power connections or something like that, so there will be difficult to get the return path for those, right? because we're going to remove the ground underneath. Apart from that, and that is a part of design rule also for this module, and I'll show you on the data sheet where it is given. So just try to make all, place all this connection in this section. So for your reference, I'm just going to place a line here so you can follow that. Okay, so start from this one. Okay, so it will go like that. You can use this section, right? So this section you can use for component placement, and just leave this section. Apart from that, for type C, so see here we have like very small space left, right? And if you'll open the type C for programmer, and you'll see here a pretty much number of component, right? We have this configuration control, channel configuration controller. Apart from that, we have one regulators as well. Apart from that, we have like few pull downs, few series termination, DC blocking, like that, right? On bus we have Zener diode, a filter capacitor. Okay, so for that, what I would recommend, just place the channel configuration controller on this section. Okay, in any orientation. You can place that now when and during the layout we will just see what orientation is favorable for the layout. Apart from that, all the resistors and all the capacitors and all the diodes, I would recommend you to place over these pins, and not randomly. You have to just follow a pattern, and whatever I did on the reference design, that I'm going to share with the today's recording. So you can just check there how I did and how you are thinking to place those component. So you can just if you are right, or if I did something wrong, you can just try your method of placing the component. And yeah, so it is just a reference, right? And if you're stuck somewhere, you can just open that project file and you can just see there. Okay, so these are the two blocks. Apart from that, okay, so now the next block I just want you to target eMMC and phi. So here you can see, so this is not the good placement, because here we have to place few component. Okay, on these pads we have to place few component, and we already have a component on the bottom layer. So what will happen if I'm going to place any component? There will be collision, right? So for that, I would recommend just create some space. Don't cross this line, because this much section will going to insert on the connector of DDR4. Okay, so just make sure here, or you can just slide this in this direction as well. Okay, so using that, you can able to create enough space for placing those components. So all the components which is on the eMMC chip, these components should be placed as close as possible to the pads. Okay, and try to distribute the bypass capacitors. So for example, open this one again. So here we have 3 bypass capacitors, okay, and here we have 4 pins or 3 pins. So don't connect all the bypass capacitors closer to E6. Okay, just connect one on E6, one on F5, one on J10, one on K9. Okay, like that. So why I removed one? So it should be 2. It should be ideally 4, because I guess few of these lines are really close to each other, or the pad is next to other, so you don't need to place so many bypass capacitor, which will be like, it will be too much and not required. So yeah, that you can follow. And next step will be the Ethernet phi connection. So this will be little bit tricky, and here you have to place all the components on the bottom, and if you'll see on the bottom layer, you have like all the space which is free. So you can use this whole section for the Ethernet phi. Let's go back to the bottom layer. Here we go. So you can see you have a lot of space which is empty here, right? So you can just place connections around, and there will be few component which I guess will not be a restriction for that. And if you'll see why I placed Ethernet phi in this direction, and I've already told you during the placement planning on last session. So if you'll see, all these connections are coming on these lines here. Okay, so it will be like directly connected here, whatever the differential connections, right? And similarly, all the other nets is going to in this section of system on chip or RK399, right? So it will be like that. Apart from that, okay, what will be the next section of component placement?